Okay, so by now you've had a chance to work through this particular portion of the problem. So I put the whole problem up here. This is from the 2018 exam. So this was just 2 years ago. And we already did parts A and B in the slope field lesson. So again, A and B were part of the slope field lesson. And so we'll check those off. I asked you to do part C on your own on that worksheet. And now what I'll do is work it through, and hopefully you can kind of check through your work and see where things went well or where there might have been something off, and see if you can make a correction on it. So I'm going to take this differential equation. So y prime is 1/3 x, and actually I'll just write it right down here. dy over dx equals 1/3 x times y minus 2 squared. And so this one, it's a separable differential, and anytime you have the x's and y's being multiplied or divided, you can pull them apart via algebraic means. And we'll write at the end here, chat about what something would look like that couldn't be separated, but the AP will only give you ones that can be separated. So this problem can be separated like the other one, but it works a little differently. So algebraically, you're just going to have to get the y's all alone and the x's all alone. And again, just as a quick recap, they gave us the slope field on this one. So pretty elaborate slope field. They then gave us 2 points, so 0, 2, and 1, 0. So that was here and here as starting values. And in parts, and then you sketch in a curve, which we did in the previous lesson. They then focus in parts B and C specifically on that 1, 0 spot. So we're looking at the point 1, 0, which we're going to use as our initial condition. So I'll put that right there. And they had us do the same estimation method that they did in the other problem from 2016 we looked at. So that's a really common thing that they ask you to do. And in parts A and B, you do not need the specific y equals for the equation, only in part C. And they use really specific language when they ask it. Find the particular solution. That means it's a separable differential, and it means you need to separate it and solve for C. Typically gets tagged 5 or 6 points on a free response. Lately it's been 5. And those scoring guides are both up in the solutions to this worksheet in that shared folder, so you can take a look down through where the point structure is, but we'll work through it here step by step. So let's begin. We'll take our separable differential, and I'm going to get all the x's to one side, and right now I'm seeing 1/3 x's on the right hand side. So I'm going to multiply both sides by dx. And again, I'm going to do this in 2 separate steps like I did on the last one. But in reality, you can combine the steps. So that's a big dx, but it's multiplying both sides by dx. And I'm going to divide both sides by y minus 2 quantity squared. Or another way to write that is 1 over y minus 2 quantity squared. And then I've got my equation separated. All the x's are together, all the y's are together, and that includes the dy and the dx. So anything involving y is on the left, anything involving x is on the right. And now what I'm going to do is I'm going to switch over to a different color pen. I'm going to integrate both sides. So we're going to integrate this thing. And for me, and again, this is just my way of thinking about it. It really helps to see it with a negative exponent. And then I'm going to put the 1/3 out front of the integral. And because it's a constant multiplier, it can sit inside. It can go out front. It's your choice. I just like it out front. It helps me to see what's going on. So what's going to happen here is I'll do the right first. So that's going to power up and divide by that power. So it's going to be 1/3 x squared over 2, or another way to write that would be x squared over 6. And again, where that 6 is coming from is 1/3 times x squared over 2. And then the 3 times the 2 gives me the 6. And I need my plus c. And again, convention is we just put the plus c over with the x. Even though it does technically show up on both sides, we just do it once over on the right, which we've covered that topic. On the left-hand side, I'm going to power up, and I'm going to divide by that power. Again here, technically speaking, we do have a u substitution going on, just like we saw in the previous problem. However, because it's just to the first power, the derivative of u is just going to be dy. You're welcome to write the u substitution in, but you do not have to. When it's a linear term like y minus 2, or the previous problem it was x minus 1, you just don't need to do that, and you can treat it just as a variable in there. So I'm going to have add a power, so that goes to -1, divide by that power, so I've got negative y minus 2 to the negative 1 power, or another way to write that is negative 1 over y minus 2. And this is my expression, again, with no initial condition. If we didn't have this 1 comma 0 sitting up here, we wouldn't be able to solve for c. You would leave it like this. Maybe you flip both sides, but what we're going to do is go get c. So now I'm going to bring in that 1 comma 0. So I'm going to bring that in to get c. And let's see, I've been switching colors to do that, so let's switch over on colors. So 1 comma 0, that's what's coming in, right? So let's put that right there, 1 comma 0. And I'm going to grab that 1 and put it in for x. And I'm going to take the 0 and put it in for y. So I've got a negative, and then I've got a negative, so those two negatives are going to give me a positive. And then I've got equal 1/6 plus c. I'm going to subtract a 1/6 from both sides, and 1/2 is 3/6. So if I go 3/6 minus a 6, I get 2/6, which is really just 1/3. So then my c value is 1/3. I'm going to take that c value and I'm going to put it back in for c, and I'm going to switch over colors to get back to the actual problem itself. So let's see, we left off and it looked like this, and then we have our x squared over 6, and then we had a plus c, but now it's a plus 1/3. So that's just taking that 1/3 and replacing the c value with it. A lot like the last problem, we're going to do a reciprocal situation. And to do that on this one, algebraically for me, what I see is, hey, I can combine these two fractions on the right. So I can get a common denominator. I'm going to multiply this second one by 2 over 2. And then I'm going to flip both sides. So I'd have negative y minus 2 over 1 equals 6 over x squared plus 2. So again, just taking the reciprocal of both sides. And if you want to write a 1 underneath this thing, if that helps you to visualize the flipping that you just did, you can do that. You don't have to, but it's up to you. So again, not necessary on that particular step. And then we have to isolate for y. And there's a couple ways we can do this. I'm going to divide that negative on both sides. So that's going to make this fraction have a negative in front of it. And then I'm going to add a 2. And convention a lot of times, again, we said is to write that positive number first. As long as you've got the right expression, it does not matter what order you write it in. And then this thing is our y equals. So we separated. We then took the integral of both sides. We used our initial condition to get a plus c. And then we isolated y. So maybe I'll check through those steps. So we first separated. So separate. We then integrate, and we're then going to add in our plus c, or our constant. We're then going to solve for our plus c, so solve for c. So again, separate, integrate, make sure our plus c is there, solve for c, and then last step is to isolate y. So 5 steps, usually gets tagged 5 points. Sometimes they'll toss in a 6th point somewhere. But this is a really common AP free response, and it's a common AP calculus AB skill. So you're taking, separating an equation, and solving. So, and that would be it. So we already did parts A and B on this equation, and this would be our particular solution that we're finding. The reason that can be separated is when you're multiplying or dividing, you can move the x's and y's strictly to one side. But if we had an equation, and so this is kind of an aside to the problem, so I'll just write an aside right here. If we had an equation where we had dy over dx is x plus y, it's a pretty simple looking differential equation, but you can't separate it. So you can't actually get all the y's and x's. If you try, algebraically, if you multiply both sides by dx, you've got this thing times dx, and there's no way to get that y over there without also dragging an x along with it. If you tried subtracting something from the right-hand side, so if instead, first step, maybe we had subtracted a y over, and you get this, you can't then multiply by dx and have it isolated, because you've got to multiply the whole side by dx, which if you did that, you'd end up with a dx on the right. You'd cancel this dx, when you arc it through, but then you'd hit the y with the dx, and so you'd have dy minus y dx equals x dx. So because of the plus or a minus, you have things tangled together. You need multiplication or division. So for the separables to work, it has to be multiplication or division. And again, the AP will only set you up with separables. But it's worth noting that there's a whole other class of differential equations. And again, there are many, many more of these things than we cover in Calc 1. They make up their entire semester of college level calculus. But we're looking at just one very specific case. And again, ours is this sort of thing where you can separate it. So it's called separable. Fun fact and aside, and I know you love fun facts, hopefully that helps kind of see and complete the picture for what is done with these separable differentials. Slope fields, estimating the tangent line, particular solution, which means separate.